Okay, let's continue. So just as a block can be placed anywhere in a single statement can be placed, it is also possible to have no statement at all in the empty statement in such places. We represent the empty statement by placing a semicolon where a statement might normally be. You wouldn't normally do this. What that means is that you could do a semicolon right here. It ends the if statement automatically, which means this line will always execute no matter what. It's pretty rare that you would want to do that. Really pretty rare. I'm not sure why there would be a valid reason why you would do that. But you can do that actually. Okay, the while repetition allows you to specify that an action is to be repeated while some condition remains true. The body of the loop can be a single statement or a block, just like an if statement. So it looks just like an if statement, except it's got the word while instead of if. And it basically says, well, while this condition is true, just keep doing it. Eventually, the condition becomes false and the repetition stops. Although you got to be careful. If you don't have a way of the repetition ending, then it just simply eventually, it becomes what they call an infinite loop, and eventually the computer will just stop it. You hope. Or you have to stop it yourself or reboot the computer. So you don't want that to happen. If the body of a while statement never causes the while statement's condition to become true, a logic error occurs. Normally, such a repetition structure will never terminate, an error called an infinite loop. Many browsers, I don't know why it doesn't say infinite loop there, but it's infinite loop. Many browsers use a dialog allowing the user to terminate the script that contains an infinite loop. So if your browser detects that's happening, and then it generally will. Here's an example here. So product less than or equal to 1,000, true. Product equals 2 times product. And the way you know that this is a loop is because there's an arrow going back to the top of the if statement, or to the top of the question. Remember, the diamond is like a question. So it's basically going to keep doing that until product becomes greater than 1,000. Formulating algorithms. Counter-controlled repetition. Often defined, called definite repetition because the number of repetitions is known. So counter-control means you're going to do something X number of times, 10 times, for example. Some other very common things that we do are something called an accumulator or a total. Very common in loops that you accumulate something or you total something up. So that's called an accumulator. And then a counter is just to count how many times you're doing something, 1, 2, 3, and so forth. We'll take a look at those. There's very simple ways of doing it, and there actually are a couple of shortcuts for doing it as well. Here's pseudocode. So here's an example of pseudocode. Set total to 0. Set grade counter to 1. While grade counter is less than or equal to 10, input the next grade, add the grade into the total, add 1 to the grade counter. And then while the grade counter is less than or equal to 10, so it's going to go and do it again. So set the class average to the total divided by 10 and print the class average. So that's pseudocode. It's not any particular language, it's pseudocode. But if you look, we can implement that fairly easily to do that. And in this particular case, they're creating a couple of variables for each one. A variable for the total, a variable for the grade counter, variable for the grade that will be entered by the user. Grade value will be the one that's converted to an integer. Var average, the average of all the grades. Total equals 0. Grade counter equals 1. Prepare for the loop. And the loop says while grade counter is less than or equal to 10, loop 10 times. And then you're going to prompt the user for a value. You're going to convert it to a grade. And you're going to accumulate it with total equals total plus value and grade counter. So If we were to try and do this ourselves, let's leave it there for starters. Okay, so right now, if I were to look at the pseudocode, set total to 0. Okay, well, I know off the top of my head that I have to declare, to convert that first statement, set total to 0, first has to be declared total, and then to set it to 0 would be like that. Set grade counter to 0. Okay, same thing. I have to say grade counter. It has to be declared in JavaScript is equal to 0. So that's the next part. Now it says while, I know I have to do that, grade counter is less than or equal to 10, do something. And I name my brackets. And then it says, okay, input the next grade. Okay, so I need a grade. And there's a couple of ways you can do it here. And I need to add the grade to the total, add 1 to the grade counter. Now, they created those variables out here, and you can do that. Of course, if you're just reading this, you could also just say var grade is equal to prompt, enter a grade. And of course, they put in a default value of 0, which we don't really need to do. They put in a default value of 0, which you don't get from just looking at this. That would be a practice. So theoretically, if I do just what the pseudocode says, I'm going to just do that. I'm not even going to put the default value in because the pseudocode doesn't tell me to do that. Although I probably would just because it's good practice. Now, add the grade to the total. So total is equal to total plus. Now, I know that I can't, that grade is going to be a string initially. So I know I can't just add it. So I know I have to do a parse in. Add 1 to the counter. And that's it for the loop. Set the class average equal to the total divided by 10. So I just take instruction 9 and convert it to JavaScript. And then print the whole thing out. So at this particular point, I can just say, they say print it out. They don't tell you how to print it out. So if I want to say alert, then I can do it that way. No reason why I can't do it that way. So if I were to execute each command as is, just based on the pseudocode, that's what I would come up with. Yes, you could. That's one of the shortcuts, Michael. I'm going to go through that. But we haven't talked about those shortcuts yet, so that's why I haven't done it that way. Okay. So now if we go back to this thing here, and we go down, now we're going to see they did it a little differently. But that's not really wrong. It's just I did it exactly as the pseudocode said. Now, I left all the HTML stuff off because wasn't necessary. I just did the actual pseudocode. So they created a total and a grade counter, which I did as well, and I initialized them to 0. Okay, so they did it on 2 separate lines. But that's not because the pseudocode told them to do that. That's just because they decided to do it that way. I tried to follow the pseudocode exactly. So I created the variables and gave them a value of 0 on the same line. Same with the grade counter. The pseudocode does not tell you to create these other variables. They decided to do it that way, but the pseudocode did not tell them that. So we go to the next page here and compare it. They're saying while grade counter is less than or equal to 10. Okay, I did the same thing. I mean, there's really no other way around it. They're saying grade. Now, they had declared that grade outside of the loop, but again, the pseudocode didn't tell them to do that. I decided to do it. I did it that way because this is the point at which they first mentioned grade. There's no reason why you can't do it this way. Var grade equals prompt, enter a grade. Now, they put in a default value of 0, and I could have done that as well, but the pseudocode didn't actually tell you to do that. It doesn't hurt that you do it, it's just the pseudocode didn't tell you to do that. Next, they've got total equals total plus what they used a grade value, but I just followed it directly, and I did the parse end on that same line. Counter equals counter. Oops, this should be grade counter equals. Okay, oops, don't really want to save it. Then their next part, which was to print out the average. Okay, so I did var average equals total divided by 10. They did the same thing, and they used the print line to write it out. Well, the pseudocode didn't tell you to use write line. It just told you to print it out. So you can see that sometimes the pseudocode isn't perfect. Although we both came up with the same solution, I tried to stick to the exact pseudocode as much as possible and used the alert instead of the document.write line. So you can see how it basically translates, but there is some room for interpretation when you're translating pseudocode to actual code. Any questions on that so far? Okay, so Michael, you said yes, we could do that, and we will later on, but. Let's call it that for now. Okay. So it asks for 10 grades, and it gives you the class average. Now, if I wanted to do that, I could as well. Just to give the minimal amount, you'd have to do something like this. Generally, you put JavaScript in the header section. This should work exactly the same way. Well, it should. Why did it? So we had an error of some kind. Is it possible? Okay. Oh, my IE may have JavaScript disabled. So enter a grade. And then we get the average. So mine one did the same thing. Slightly different way, but it did the same thing. How important is pseudocode? It seems not that valuable. Actually, it's very valuable. It's very valuable. What happens very often is that semi-technical analyst types will actually write the pseudocode for you. And the thing about the pseudocode, why it's valuable too, is it's English enough like and structured enough like to where most people, even non-programmers, can follow it. They can follow that logic. If you look at this here, this is English. I mean, someone can walk through it, and this is very simple. But let's say you're doing something more complex. I mean, this allows you to walk through the logic and say, if this, do that. So actually, this is very valuable pseudocode. I mean, it allows non-programmers, even people that aren't necessarily that technical, to use it, to understand it. An outliner for writing pseudocode? Sometimes, yeah. Okay, JavaScript represents all numbers as floating point numbers in memory. So JavaScript has essentially got two types. It's got numbers and strings, and objects, three types. Your primitive types are essentially numbers, which it represents as floating point numbers in memory, mainly because that's the most flexible. It'll hold any type of number. And most other stuff it stores it assumes it's a string, because that's the most flexible data type. And then there are other objects that JavaScript recognizes as well, including the data object. Computer allocates only a fixed amount of space to hold such a number. So part of the reason it's going to use a floating point value if you want a number is so that it knows there'll be enough space there for it. The string is passed to parseInt, contains a floating point numeric value. ParseInt simply truncates the floating point part. So, for example, 27.95 becomes 27, and negative 123.45 becomes negative 123. If what you want is a floating point, then you have to use parse float. There's another one called parse float that you can use. They don't mention it here, but there is a parse float that will store the entire floating point number in there. Sentinel controlled repetition is where you have a sentinel value that's also generally referred to as a dummy value or a flag value that indicates the end of data entry. Often there's an infinite repetition because the number of repetitions is not known in advance. You should choose a sentinel value that cannot be confused with an acceptable input value. So, for example, our sentinel value for this same application might be -1, because that wouldn't be a possible grade. No one's going to get a -1 unless it's a really mean teacher. I don't know how you get a -1. Top-down stepwise refinement, a technique that is essential to development of well-structured algorithms. Approach begins with pseudocode of the top, the statement that conveys the script's overall purpose. Divide the top into a series of smaller tasks and then list them in the order in which they need to be performed. First refinement. Second refinement commits to specific variables. So with pseudocode, if it's written well enough, you can do what I just did and literally translate each line of the pseudocode to one or maybe two lines of JavaScript code. So if it's well written, and it should be well written enough to where a layperson can read it and a programmer can easily translate it into a programming language. That's good pseudocode. I work with doctors all the time when we use pseudocode. And the doctors can understand. Actually, some of my doctors have figured out how to write pseudocode because they're smart. So now they just send me the pseudocode. These are, depending on who your users are. In my case, I'm dealing with people that are better educated than me in many cases. Pseudocode is something they can easily follow. It really helps to explain, and they understand the logic of what's happening. Each refinement, as well as the top itself, is a complete specification of the algorithm. Only the level of detail varies. When performing division by an expression whose value could be 0, explicitly test this case and handle it approximately in your script by displaying the error message rather than allowing the division to write. So this is division by 0 would be one of those fatal errors that you cannot continue from. So if you're inputting numbers from your users and you're going to use that number in the denominator, or is it the numerator? Numerator? It's the numerator, I think. The numerator, then division by 0, so that would be the denominator, excuse me. Then you want to check for that in an if statement. Algorithms generally can be divided into 3 phases: initialization phase, processing phase that the input values are done with, and termination phase. This used to be called, when I first started this was referred to as input process output, or IPO. Yeah, not initial public offering, input process output. Although years later with all the startups, people generally prefer to think of it as the other way. So here is another example. Initialize total to 0. And what I'm going to do is I'm just going to grade counter to 0. Let's just do what this says. Input the first grade, possibly the sentinel value. Do exactly what they say. Okay. Possibly the sentinel value. And generally you have to tell them what the sentinel value is. Of course, the pseudocode doesn't tell us to do that. While the user has not entered the sentinel value, do something. Okay. So now, instead of it being that, it says while the grade is not equal to the sentinel value. And I'm going to say the sentinel value is -1. We have to give it a value. We're going to say -1. Add this grade to the running total. So that would be that one there that we did earlier. Add to the grade counter. Next is input the next grade. So I have to get rid of this variable because I already declared grade. If grade counter is not equal to 0, okay, so this is here at the end, because we don't know. They may have never entered a grade. So what we're going to say is if the grade counter is not equal to 0, grade counter is print set the average to the total number by the counter, print the average. So that's these two here. It's more than one line, so I have to do that. Else, it wants us to print no grades were entered. Because that's following that pseudocode exactly. Now, I don't know what the sentinel value is, but if I enter -1, I know what it is. No grades were entered, right? If I go through and I say, and I enter -1, average is 26.4. Oh, I know why that happened. That's a logic error. I divided by 10 when I should have divided by the counter. Okay, so the only problem with this thing here is that I don't tell them what the sentinel value is. But the pseudocode doesn't tell me to do that either, so I just follow the pseudocode. The program does everything else, though, correctly. It initializes total and grade counter to 0. It inputs the first grade. While that grade is not equal to the sentinel value, which is -1, add this to the total and add to the grade counter, and then prompt for another one. Comes around and checks again. If the grade counter is not equal to 0, I said greater than 0. I could have said not equal to 0. I mean, if we're going to follow it exactly, we probably should do that. So this works. The only problem is, well, the way you would do it is something like this. -1 to n. Something like that. Now, I knew that, but I'm just being a stickler to the pseudocode and doing only what the pseudocode told me to do. Now, when we look at their example, we're going to see that they did just that. They entered that in there. And, you know, obviously, say 1 to n. Okay, obviously, you know, if you're a programmer, you're going to probably try and think of that something, but it's not there. So you can see that there's actually a little bit of a problem with the pseudocode. The pseudocode probably should have said somewhere here, enter the first grade, tell the user what the sentinel value is, or something like that. The pseudocode didn't do that, so I just followed the pseudocode exactly. Right, so we'll look at what they did, but my guess is that